Welcome to sections 5.2 and 5.3. We're going to combine these sections because the information overlaps, and we're not going to do everything that's in these sections if you look at what's covered in the text, but we're going to put them together and kind of give you a background in rational functions. So the first thing that we're going to do is start off with one that's familiar, and that's the graph of 1 over x. So if you remember back to our graphing section when we did the library of functions, we talked about 1 over x. We looked at a lot of points for that. If you want to go back to the slideshow, it's still in study aids. And we talked about how when x gets very, very big, this whole fraction gets very, very small. And when x gets very, very small, the whole fraction gets very, very big, because that's what a reciprocal does. And so what ended up happening was we had this graph that kind of looked like this. Okay, that should look familiar. And if you remember let me see if I can draw it in with paint. The y-axis was an asymptote, and the x-axis was an asymptote, because we got really, really close to 0, but we never actually reached it. And we could plug in numbers that were really close to 0, but of course we can't have 1 over 0, so we never reached that. And then on the negative side, we got the same exact thing over here. All right, so I know my graphs aren't great in here, but we got a graph that looked like this, and that should look familiar to you, those two L-shaped pieces. All right, so we're going to take those kinds of ideas of what we were looking at there and try to extend this onto some other rational functions, because this one is the most basic rational function. So let's try to see if we can use this to look at 1 over x squared. All right, so anytime we want to look at a graph that we're not really familiar with, we usually plug in some points, right? So let's go ahead and do that now and see if we can see a pattern that makes sense with what we already know. All right, so for x values, let's plug in some numbers like 1, 2, 3, 4. And what happens when we plug these into, I can make this into an equation, same difference. All right, what happens when we plug x in? Well, we're going to get y is equal to 1 over 1 squared, that's 1. 1 over 2 squared, that's 1 over 4. 1 over 3 squared, that's 1 over 9. 1 over 4 squared, that's 1 over 16. This is looking a lot like it did for 1 over x. Our y values are getting small. They're getting even smaller than they did before. And so the same idea over here with 1 over x squared is that we're going to be getting closer and closer to the x-axis as an asymptote. All right, now let's see what happens with numbers between 0 and 1. Remember, we had to look at the fractions to see what was going on. We still can't get to 0 because we can't have 1 over 0, but we can have all these fractions. So when we put fractions in, let's say we do 1/2, 1/3, 1/4. Okay, so what's going on here is we're going to have 1 over 1/2 squared. So we're going to square it, and then we're going to flip it. As it turns out, it doesn't matter which way you do this, because 1 over x quantity squared is the same as 1 over x squared, but we'll go ahead and stick with the way that it's written here. So when we square this, we get 1/4, and then when we flip it, we get 4. 1 over 1/3 squared. So we square it, we get 1/9. We flip it, we get 9. And 1 over 1/4 squared. We square that, we get 1/16. We flip it, we get 16. All right, so as our numbers are getting smaller and smaller, closer and closer to 0, our y values are getting bigger and bigger. So that's going to look like this. Okay, now my graphing in this program is not fantastic. It's hard for me to do details. If we saw this compared to the 1 over x, you would see that it's a little bit more L-shaped than the 1 over x graph, but pretty much the same idea. All right, so that's on the positive side. Our positive L piece looks the same. Let's plug in some negative numbers and see what happens. Okay, so the same thing, but let's do -1, -2, -3, -4. Well, when we plug these in, we're going to have 1 over -1 squared. Now, because of that square, these are all going to come out positive. So we're going to get 1 over +1. We're going to get 1 over positive 4, we're going to get 1 over positive 9, and we're going to get 1 over positive 16. Okay, and then we can do the fractions as well, but you can probably see that they're going to come out the same too. So when we put them in, we're going to square them and flip them. They're also going to come out positive. Okay, so on the negative side, when x is negative, we still get the same y values. So we're going to get like this and like this, with the y-axis being an asymptote and the x-axis being an asymptote. Let's put those in blue so you can actually see the asymptotes here. Okay. Okay, so we can see some similarities in what's going on here, but the pictures do come out differently. All right, on the positive side, they look similar. They've both got those L-shaped pieces, but the 1 over x squared graph is symmetric to the y-axis because both sides come out positive for y. 1 over x, if you remember way back, we talked about that being symmetric to the origin. And what that means is that you can rotate it 180 degrees and it comes out to the same picture. Okay, so other ways that they're similar is we know that the domain for 1 over x is anything except for 0, because we can't put 0 in the denominator. And the same thing for 1 over x squared. The domain again is everything but x equals 0. And we can see that with an asymptote at 0. An asymptote means that the graph can't exist there. All right, so this gives us some basic graphs to look at. So let's erase the 1 over x that we have. And let's see if we can graph some variations on this. So we're going to have, we've already looked at some variations on 1 over x, if you remember back. If we do something like 1 over x plus 3, we take the picture of 1 over x. This plus 3 is on the outside of the function because it's outside the fraction. So this plus 3 is going to move the picture up 3. And remember, to move these, we're going to move the asymptotes. So we're going to go up 3, 1, 2, 3. That's the new place for our asymptote, like this. And we fill in with the 1 over x picture. So we've got L-shaped piece there, and L-shaped piece there. Okay, now we can do the same exact thing for 1 over x squared. So we could have 1 over x squared, let's say minus 4. So we know what 1 over x squared looks like now, and the minus 4 is outside that function. Okay, remember, outside the function moves us up or down, and it's what you would expect. So this is going to move us down 4. So again, we move the asymptote down 4, 2, 3, 4. So now our asymptote is down here. Our asymptote stays on the y-axis. And now we have the two L-shaped pieces, but remember they're side by side for 1 over x squared. This one is the 1 over x squared graph. So we're going to go like this on the positive side, as we did before, and then mirror image on the left-hand side. Okay, so there's 1 over x squared minus 4. Okay, so moving along, remember if we had something like 1 over x plus 5. All right, so we see that this is a 1 over x type function. We've got plus 5. The plus 5 is on the inside of the function. And remember, inside the function, which for this one is inside the fraction, inside the function moves left and right, and it's opposite what you would expect. So this is going to move us to the left by 5. To the left by 5. So we draw our picture. We're going to go 1, 2, 3, 4, 5 to the left, and that's where we draw on our asymptote. Asymptote stays on the x-axis for this one, and we're going to draw in the 1 over x picture. So that's L-shaped piece here, and then L-shaped piece diagonal from that. Okay, now for 1 over x squared, same idea. Let's say we have 1 over x minus 2 squared. Okay, so we see that squared, and we think 1 over x squared, and the minus 2 is inside the function. Now for 1 over x squared, it's got to be inside the fraction, and it's got to be inside the square. It has to be both of those things. So this minus 2 is inside the function. Okay, inside the function is left and right, and it's opposite what you'd expect, so this is going to take us to the right by 2. So we're going to move this asymptote to the right, like this and like this. And now we're going to fill in with the 1 over x squared picture. So we've got this piece here, and then mirror image, this piece here. Okay, so this gives us some basic graphs to start with. Now, we've got to be careful with this 1 over x squared one, like I said. Let's say we have the graph 1 over x squared plus 3. 1 over x squared plus 3. So we see this x squared right here. We see this x squared, and we think, okay, I know the x squared graph, but the problem is this plus 3 right here, it's not inside the function and it's not outside the function. This plus 3 doesn't match what we've been doing. So to be inside the function, it's got to be inside the fraction and inside the square. So this plus 3 is not a simple shift. We're going to have to do something else with this function. So what we do with other functions that aren't exactly 1 over x and 1 over x squared, we're going to see in the next video.